This is the XStream Trucking design team. You'll have to remind me, what's your name?
I'm Shubha.
Shubha, that's right. And Adam. So Adam is a client of mine. I've been developing electronics alongside with him, and really actually, he's been doing most of the development, and I've just been doing design reviews and things because he's super brilliant and knows what he's doing. So they're developing a system to save fuel on trucking transportation. I'm going to let them talk more and more about what it is. But as always, anytime you're at a BlueStamp guest speaker, I encourage you to ask questions, interrupt, be like, hey, can you tell me more about how you lost like $100,000? Feel free to say stuff like that. I want to make sure that you get all your questions answered and we get to what you actually want to talk about. So while they're getting that set up, I'll let you guys get started, or do you want the slides?
Oh, yeah, no, we can tell the slides work is one thing that we actually have. Is what, what age range do you guys, are there any people in the 7th grade? No? 8th grade? 9th grade, or is it even earlier? Is it, what's the age range?
Rising freshman through graduating senior.
Oh, right, in high school? Oh, cool. All right. So what's really exciting is that one of the things we're going to share is kind of where we got to in our career. So I'm pretty old. I'm 29, about to be 30. Pretty excited. And I've been in my career for a long time. On the flip side, Shubha is kind of just beginning her career. So she's much closer in age range to maybe some of you. Well, what we're going to start our slides with is kind of the journey we took and how we got here to the Bay Area. I'm originally from Northern Virginia. I'm Laura. Yeah. So I'm from the East Coast. And how did I get here? How did I become working at a truck startup, asking Dave Young for help making PCBs at a small company? How do you make that happen? It's kind of like, you know, it's kind of hard. So I'm going to show you what, just quickly before we start, we're going to show kind of our kind of stories. And we'll kind of go from there. And feel free to the early parts to ask questions or save them for later for career stuff, which is always exciting. So yeah, so this is the guest lecture. I'm Adam Baumgartner. This is Shubha Jagannathan. She just beats me for name length, so I'm pretty sore about that. But yeah, so we can go to the next slide. So I just wanted to, I think the next slide should show my trajectory. Is it change? Oh, sorry. Oh, sorry.
Do you want me to?
Oh, yeah.
Okay.
We can hand it back and forth. So this is a quick map showing where I'm from. So I'm from Northern Virginia, here on the other side of the country. We call it Northern Virginia because if you just say Virginia, people get really confused. They like talk slower around you. You're like, no, Northern Virginia, special county, Fairfax County is pretty sweet. I went to school in Baltimore, Maryland at Johns Hopkins University. While I was there, I got to play basketball. I was on this off-road vehicle design team. It was really exciting. I was a mechanical engineer. And after I graduated, it was really hard to get it. It's hard to remember what it was like in 2010. But like nobody had jobs. Everyone was. It was like amazing that I was very lucky to get a job, and I worked for Honda R&D. And I did two main things when I was there. I went to Columbus, Ohio. That's this state. It was like literally right in the middle. And what I did is I did a lot of CAD design. I worked on the structures of cars, like the crash tests. And then after I did that for a few years, I switched it up, and I became a test engineer, where I did acceleration performance for cars. So this was a car that was all camoed out. We were doing a hill climb test in Death Valley. This is a spy photographer took this photo. So that was cool. I really enjoyed that. But finally, like I wanted to try something different. So I wanted to switch to more of an electronics track. So I worked for a company called Polaris. They make snowmobiles, ATVs, side-by-sides. And they had an office that was in northern Minnesota. It's really cold here. So like as a quick test, so we're going to see what's the coldest temperature people have experienced. So who, raise their hand if they've seen it be 10 degrees Fahrenheit. 10 degrees Fahrenheit, 10 degrees. Okay, all right, put your hand down if you've, unless you've seen a zero, keep it up if you've seen 0 degrees Fahrenheit. Okay, how about minus 10 Fahrenheit? Okay, how about minus 20? Okay, well anyways, it went to minus 40 one day. And at that point I was like, was Fahrenheit or Fahrenheit or Celsius minus 40? They're like, doesn't matter. That was very cool. Anyway, so I did that for about a year where I worked on snowmobiles. I did the kind of calibration. The snowmobiles are just like a car. It's actually tuned. It's a big table for how the engines are tuned. And then I switched that up, and now I work as an embedded systems engineer with XStream Trucking. And I've been there for about a year and a half. Switch it up. I'll talk it for you.
All right. Thank you. So, hi everyone. I'm Shubha, and my scope of moving around is much less than Adam's, so here's a map of the Bay Area. I'm from Mission San Jose High School. I don't know if anyone from
Mission San Jose?
Hey! Yeah. I graduated not very long ago, just a year or two ago. And when I was there, I was really involved in electrical engineering and really interested in the arts and just being creative. So the thing that really appealed to me was doing, creating using electronics. So I decided to go to Berkeley and study electrical engineering and computer science, and that's where I currently am. And I'm working with Adam this summer, and it's been a really incredible opportunity to explore embedded systems engineering, which is a highly creative field. You get to meet makers from all kinds of backgrounds, and we're creating all kinds of really cool things. And I'm really excited to be working with XStream this summer, working with this fuel-saving aerodynamic product.
Yeah. Any questions so far? Yeah.
What is embedded systems?
Embedded systems engineering is kind of, if you've heard of Internet of Things, it's kind of using electronics and using that to work with devices. And for us, it's the truck wings, our product.
Yeah. Any other questions before we go on? Oh, right. You guys are a great crowd. Great crowd. Gotta say. So next we're going to talk about the truck wings. So I'll handle this slide. So here's basically a map of kind of what our product does. So our goal is to reduce the fuel economy, is to improve the fuel economy of semi-trucks. These are big, we call Class 8 trucks. You definitely see them on the highway. They, go by. You make it really intimidating. Like you're just trying to learn to drive, and here comes this guy with this 80,000 pounds. It's really intimidating. So this is the environment that we work in. So these trucks drive a lot of miles. In fact, typically in an average week, these trucks drive about 5,000 miles in 5 days. Then they take 2 days off, and then they do it again. That's usually because they go all the way across the country and then all the way back. It's really impressive. This is how a lot of goods that go to Walmart, Targets, all sorts of things get moved. Because they drive so many miles, any little bit of improvement actually has a really big bottom line. So our product that we make, the truck wings, is a device that when opened, these kind of folding panels that open, they close the gap between the cab and the trailer. Now you may wonder, this seems like a great idea. Why don't they just always have those panels there? Well, unfortunately, when the truck turns, these panels would, when the whole box rotates, if you look from the top, the truck would actually, the trailer would smash through those panels. So we need a way to automatically open, automatically close those panels. Any questions about what we do for saving fuel economy, for improving fuel economy on trucks? Yeah, go ahead. What's your name?
Oh, Anand.
Anand, it's nice to meet you.
Nice to meet you. How much more efficient, or how much fuel does it save by streamlining?
Yeah, with that 5%, which it's about 5% fuel economy improvement. And because the trucks are at this highway speed for those 5,000 miles, it ends up being about $50 per week per truck. That just out of thin air that we make. Any other questions? Yo, hi.
Hi. How does that save money or how does?
Yeah, no, great question. So when do you want to add?
Sure. So the fuel that you use to move the truck is overcoming a lot of friction. So there's friction on the road, and then there's friction from the air that is moving against the truck. And this is helping make the truck more aerodynamic, so it's helping overcome kind of the air drag that this truck is facing. And because it's using less fuel to overcome that friction, you're saving fuel.
Yeah.
How do you guys measure the 5% fuel economy improvement?
Yeah, so we actually have a number of ways. The truck knows how much fuel it uses. So we have real-world tests where the trucks are driving over the course of a month. And we're actually able to, we had another truck driving right next to it. So you have to, because weather variability accounts for quite a bit. So you have basically 2 trucks driving, one has the device and one doesn't. And so they're basically just driving, and you observe and you have the same load. And then you make that as your kind of baseline test. So we measure the amount of fuel that they use. We also validated it using wind tunnels. Well, what we found is actually, it's funny, as you were asking, how does this save fuel? Well, the wind, when it gets between the gap between the trailer and the cab, it actually goes to the back of the trailer, it makes a big sail, and it's a really interesting aerodynamics case. This cuts that off from happening. And in the wind tunnel, we're about 3%. And then in the real world, we're actually more like 6%. So we say 5%. But it's actually, because in the real world you have all these like crosswinds, especially in the Midwest where these trucks drive quite a bit, we actually, that's how we started to see our savings. We did a wind tunnel, made a little 40% scale model, and then now we have a real world testing. So yeah, great questions, guys. So one thing we also wanted to talk about is we want to talk about our team. This is what our team looks like. We just got a new office, so we're super excited to show it off. We just had a design day on Tuesday, which was pretty exciting. So Shubha, any other thoughts for the team?
Yeah, so XStream is a startup. We have about 10 regular employees and 4 interns right now, and it's really great because you don't have to go through a lot of people to get anything done. And so yeah, as Adam was mentioning, we had a design summit where everybody in the entire company got together and we brainstormed ideas, and everything moves really quickly. So it's a huge opportunity for learning a lot of different aspects of how a company runs and how a product is created.
Go ahead.
Oh, sorry.
Oh, do you have, no, please.
Is there any reason you guys chose to go with a smaller team instead of a much bigger company with more people?
Yeah, well, we are a startup, so it starts from a small team, and as we grow, we'll probably gain more people. But yeah, as I said, communication is really easy, and yeah.
So I also chose a startup because I wanted to. There's a lot of risk. Like you're in a situation where you have I have equity in XStream. Would love it if you're interested in talking more about like kind of choosing a startup in your career versus choosing a larger company, the pluses and minuses. But yeah, I was looking for an opportunity to really expand my opportunities to learn. When you're at a startup, there's really no one in charge of if something's supposed to work. It's really all on you. Whereas in a larger company, there's kind of usually there's a hierarchy and there's more of a structure. Sometimes though, that structure is not what you want to work on. And if you want to, you can learn more skills sometimes by joining a smaller company with less structure, and you'll make more mistakes. And it's when you make those mistakes that you really get to some great learning opportunities. Great question. So yeah, so now we're getting, so that was kind of the overview, kind of what we have, what we do at XStream Trucking. What we're going to do, we got 2 more slides. Really appreciate you guys' time. We want to talk about 2 main aspects of our part of the system, the Carbon Connect, which is the thing that controls the panels. We're going to talk about the hardware, which I think you guys are working on a lot of, the actual bossing those electrons around, making sure they go to the right places. We're going to talk about that. The next part, Shubha's going to talk about the software and kind of how the firmware was developed and techniques we're still working on and how we solve problems in the field. So I'm going to go first with the kind of hardware. This is an example, so there's a lot of pictures here. I think it's a little grainy with the light, but what I want to show is I want to kind of walk you guys through how in 10 months we went from kind of like an image of like we want something that controls trucks. Oh yeah, I think it's also worth mentioning. So XStream Trucking is really new. We've been around for about 2 years. So so if 3 years ago you Google us, you wouldn't get anything. But now you do. So this is to your point about what's cool about a startup is like we get to work on things that are super fresh, super hot, super moving. Another neat thing, so I'm as you kind of saw from my career path, I'm a mechanical engineer, and learning more of these embedded system skills and software skills, which has added a lot to my career, kind of adding these extra bits. What I want to show is that we essentially, the technology we're using, nothing, we're not showing any tech that is like revolutionary. And the bar to get to where we are now, which is a mass-produced product that is being made in Mexico, it's actually pretty low. So within 10 months, we went from like this to having to just roll off the assembly line. These are all the individual little PCBs that go into this. So what we first did, what I want to kind of just share, So yeah, so what we do is in the development of a board, which I think you guys are going through too during this summer opportunity. Of course, first you start with a breadboard, and you figure out how does all of the individual components work. So and then stepping one back further, we actually just designed some boards from SparkFun and Adafruit that did exactly what we want. We then found how they did that using the PCB software. We then created a version of what we wanted. We then, this is the next step. We okay, does it fit on the board area that we want to be? Like, okay, great, it fits. And then we're like, shoot, we need to figure out something to put it in. So then we made an enclosure, and then we iterated from that opportunity because we then put the breadboard inside the enclosure, and then we found out people don't like the way the front works, or they want, instead of a knob, they want a screen. And it's this iterative process where you have a really flexible assembly where you can make circuit boards. You have the breadboard where like, you can do all the circuit design to check it. And then you have 3D printers. Now, unfortunately, we were in such a rush, I forgot to bring the box that this actually is. But what I want to show is that after doing those 4 things, where you've got all this opportunity to like really make changes and see improvements, you then are able to get feedback in a really agile way, and then keep working on iterating them. And then finally, now we just, it was like as simple as like, because we were doing it iteratively, we then finally just reached this point where we're like, great, it's all smooth. And then we just, instead of making 1 or 2 a week, we make 15 a week. And then we make 30 a week. And that's really exciting. So when you're working on all this stuff, remember that sometimes it's easy to get distracted and think, oh, this is going to take forever, I'll never finish this. Every little bit adds on it, and then before you know it, you're in a position where you're ready to just turn it up and have more units be produced. That's what it was like on the hardware side. Any questions about the hardware side?
Does this look familiar to anyone?
I bet. I know, you guys are so, you must love doing this. You guys seem so energized. But yeah, so I want to leave some time for questions, so we're going to jump to Shubha, who's going to talk about the firmware.
Yeah, for sure. I also want to mention, so Adam mentioned agile development, and this is a huge thing that we do, especially in a small company where you need to have a working product. So Adam was saying, we do iterations, but everything works. It does the minimum of what it's supposed to do, and then we improve on that. All right, so this summer I'm working on the firmware, and this is basically programming our device, the hardware, to do what we want it to do. And firmware can be, in our case, it's getting the location, the speed, distance traveled, and this is also the place where we can add new features. Like we have the software, and we have the device, which we can program and make it do new and cool things. So, next slide. Yeah. So firmware is programming the microcontroller, and we need to establish a means of communication with the microcontroller and outline how it's going to be used. And so some of the things we do are sending commands to the microcontroller to say, here's what we want you to do. And we also receive data from the microcontroller. And this is how we make sure our device is working and are able to provide the data to our customers. So some of the examples of commands we send are, hey, I want you to check the average speed for every minute and send it to me. I want you to check, after I tell you to open the truck wings, I want you to check that the truck wings have actually opened. Another thing we like to ask our device to do is to send data to the web. So we're able to provide some data for processing and analysis for our customers. And we also want it to be kind of we program fail-safes. So if anything goes wrong, I want you to reset, or I want you to send me a notification if something goes wrong. The data we receive involves the speed of the truck, the odometer readings, and the state of the truck wings. So we ask it to send us the data, and it'll send us the data. Other stuff is the GPS location of the truck, and just the basic functionality of how we use the device. So here's a very rough example. The microcontroller we use can be updated. The software can be updated remotely. So sometimes something we used to do is when the truck is in the field and driving, we're able to flash software from remotely and update the software on the microcontroller and get it to do new things.
Yeah, and as you were talking about, so we're 2 people on the embedded systems team with XStream Trucking. There's also a whole team of mechanical engineers that work on improving and optimizing the way that the panels open and close. And a lot of times it's very cool. So we're able to give them data. For instance, someone wants to know, hey, how many times does it open and close over a week? And we thought, well, maybe like 30, and we're like way off. But because it actually counts it. Like, it was neat that we were able to actually help support other teams with the use of our product that we work on. Any questions? Shubha? Any life questions? Actually, yeah, do we have questions? So yeah, So yeah, what do you guys think? What do you guys think? Any questions? Any thoughts? We got some great questions before. I would love a few more. Anybody has any? Yeah.
Please,
So I noticed you say you open and close based on how you turn.
Oh, it's actually speed.
Oh, speed.
We use speed. So when it's above highway at highway speed above, let's say 55 miles per hour, they'll open. And then when you slow down, like when you're getting off the exit, if the truck slows down, they do have to close because you turn.
Oh. Okay.
So the goal is to be, when you're going above a certain speed, the amount that you can turn is pretty small, like lane changes. But when you slow down, because otherwise it'll roll over. So I guess it's possible that they could stay open while you roll over. That's something. But we'd be saving a little bit of fuel before it did.
Great question.
Yeah, so you said there were like 14 people in the company. So like how many teams could you have with like a lot of people?
Oh, well, so how many teams could we have? Oh yeah, because we're just 2 people. Oh yeah. The rest of the team. So well, that includes our CEO. So he's okay. So that's 1 more, and then we've got a salesperson. That's now we're 4. The other 10 people are working on the mechanical side of it. There's a pneumatics part that opens. Like there's also the big cost drivers. This physical thing. The neat thing about like updating firmware and adding features through software is that it doesn't cost anything. It's just new features you're repackaging what already exists. It's actually more expensive. Stuff that are like the mechanical thing. They have 10 people. Currently, before them was 3 of those are interns, so it's 7 people. So I guess normally it's just me, 7 people, boss, and the salesperson. Yeah.
So you also mentioned that you can flash firmware. You can flash the software even though it's not like connected to.
Oh yeah, we can flash over cellular. Yeah.
So you flash over cellular. So how does that sort of work? How do you enable that to happen?
Yeah. So we use an off-the-shelf solution, but what it does is it takes the data. It is compiled in a certain binary, then it's sent over cellular, and then there is a kind of a process that allows that checks it, and then sends a checksum back to the part that sent it out, confirming that the software was effectively sent. So it's a pretty neat system. It's been really effective for us to be able to, because we can't tell these trucks to stop. They're busy making money, so we have to find we use that as a really effective way to send stuff. So not only can we receive data over cellular, we can also send new firmware. And that's really cool technology. And it's an off-the-shelf solution that we currently use. So it's something you can buy, which is neat.
Ooh, that'd be a great way to communicate with your Arduinos, guys.
Yeah, I'm sorry. Hi.
What's the language that you guys use?
Yeah, so the language is kind of called Fire. It's a mix of C++ and C. It's an Arduino language. So yeah, if you go on Arduino and look at the
Oh, are you guys using Arduino?
Well, so we write it. Well, so that's what it was. We started that way. So recently, one of the things that Shubha was doing actually is changing it from a Arduino style to actually more of a C++ style.
Oh, cool.
It's pretty cool. Yeah, it's pretty. So yeah, go ahead.
And what's like the advantage of switching over?
So we decided to switch over to the C++ style because I kind of encapsulated everything in classes, and so I can access different functions really easily in classes. And this enables us to add new features really easily, and it helps us with the organization, I guess, of being able to use and modify our code.
Great question.
We have time for one more question.
All right. No worries. Actually, instead of making one more question, can we get a team photo? Oh, sorry. You have a question? Sure. Yeah.
Yeah, so like she said she's from embedded, right? So are you like trying to compress the circuit size? Are you trying new ways to like compress the size totally? Finding new assemblies maybe?
So, are you saying, like, are we trying to make our circuit board more compact?
Yeah, because your breadboard is more like this, and
Yeah.
then it goes.
So, so this is the, like, agile development we were saying. We started out with this massive, messy looking breadboard, and then streamlined it into a smaller, more effective and more efficient product. And that's what we're doing with each iteration. Currently, since we've been working on streamlining this circuit board,
Awesome, thanks so much, guys.